We will see part 11 of 8086 instruction set. The first instruction is IMUL or signed multiply. All the rules are exactly the same as that of unsigned multiplication, except that the operands here involved are signed numbers. Okay, so IMUL multiplies signed byte or word operand with the contents of the implicit destination, that is x. So if you are using a byte along with IMUL, right, the destination will be implicitly L, and if you are trying to give a word over here, the destination will be x. And note that we need to store the result, right, and it will be twice the size of the source that is specified here. So if you are giving sources of byte, then the destination has to be a word. Okay, so the result will be a word, that is, it will be in x. And suppose you are giving the source as a word, right, the destination will be ax and the result should be in dxx. Okay, because we need twice the size to store the final result. So for byte operands, the result you can get in x. Then for word operands, the result will be in dxx. Then as usual, you can't use immediate operands. Then one extra thing to note here is, here the unused higher bits, right, they are not filled by implicit zeros, they will be filled by the sign of the result. So if the result is negative, then the unused higher bits will be filled with all ones. So these are some IMUL examples. So in the first one, the operand is a byte. Second case, the operand is a word. And in the third case, the operand is a word which is stored in primary memory. Okay, and this is one numerical example. Here we are moving -2 to L, then -4 to BL, then we are giving IMUL BL. So we are trying to multiply a byte, right? So the destination will be automatically AL, or the other operand will be automatically AL, and the final result is supposed to be in AX. And as the result is supposed to be positive, right, the excess bits in AX will be filled by 0. Next we will see IDIV, which is signed divide. Okay, it is just exactly the same as DIV, only thing is signed operands are involved. So it divides signed operand in accumulator with the source. So the dividend is in accumulator, the divisor is our source, right? So divisor, you are specifying it as part of the instruction, that is IDIV. And as usual, immediate operands are not allowed. Now this table just tells us where we can find the remainder and quotient. Suppose that our dividend is residing in x and we have a byte source, right, or the divisor is a byte. In such a case, the remainder will be in h and the quotient will be in L. Suppose that our divisor is a word or the source is a word, right, then dividend is supposed to be spread across dxx, right, with the most significant bits of the dividend in dx and least significant bits in x, right. Then where can we expect remainder and quotient? Remainder we can expect in dx and quotient we can expect in x. Then as usual, the overflow at the time of division, right, is indicated using divide error exception, especially when there is a division by 0 case. Let's see an example. Suppose we have in x -203, okay, whose binary representation is this, right, 2's complement representation is ff35, and our divisor or source is 4. Okay, then if we are issuing IDIV BL, right, what happens is the quotient you can find in AL and the remainder you can find in H. Both are negative and they will be stored in their 2's complement representation.